Industry, ambition, adaptation. Born under Cold War pressure, these aircraft marked the rise of a new aviation power. Built to learn and evolve, this era laid the foundation for China's modern military aviation. Our journey starts with early jet and reverse-engineered foundations, 1950s to 1960s, Shenyang J-5. This aircraft marked the beginning of China's jet age. Built during the early Cold War, it provided valuable experience in jet operations and mass production. Although limited in range and avionics, it established the foundation for pilot training and industrial capability in high-speed combat aircraft. Shenyang J-6, developed as a more capable successor, this fighter introduced supersonic performance and improved climb rate. It became one of the most widely produced jet fighters in China's history. Used extensively for air defense, it formed the backbone of frontline fighter units for decades. Shenyang J-7, designed as a high-speed interceptor, this aircraft emphasized speed and altitude performance. Continuous upgrades over many variants improved radar, weapons, and survivability. Its long service life made it a key transition platform between early jet designs and more advanced indigenous fighters. Next comes indigenous fighter and strike aircraft, 1970s to 1990s. Nanchang Q-5, developed for low-level strike missions, this aircraft was optimized for speed and survivability while attacking ground targets. It emphasized precision attacks against airfields, armor, and infrastructure. As one of the first major indigenous combat designs, it marked a shift from adaptation to independent development. Chengdu J-8, designed as a high-speed interceptor, this aircraft focused on altitude, climb rate, and long-range interception. It represented a major step beyond earlier reverse-engineered fighters. Although limited by early avionics, later variants improved sensors and weapons, bridging the gap to modern Chinese fighter programs. After that, modern 4th and 5th generation fighters, 2000s to present. Chengdu J-10. Designed as a lightweight multi-role fighter, this aircraft emphasized agility, modern avionics, and beyond visual range combat capability. It marked a major leap in indigenous design, moving away from interceptor-focused doctrine. Continuous upgrades have kept it relevant as a frontline platform in modern air combat. Shenyang J-11. Built as a heavy air superiority fighter, this aircraft focused on range, payload, and sustained high-performance operations. It provided long-endurance patrol capability and strong missile loadouts. Indigenous improvements gradually reduced reliance on foreign systems, strengthening domestic aerospace expertise. Shenyang J-15. Developed for aircraft carrier operations, this fighter emphasized reinforced landing gear, folding wings, and naval strike capability. It enabled fixed-wing aviation from carrier decks and expanded power projection at sea. Operational experience contributed to later improvements in carrier-based aviation design. Shenyang J-16. Designed as a multi-role strike platform, this aircraft focused on electronic warfare, precision strike, and long-range missions. Advanced sensors and payload capacity allowed complex battlefield roles. It represents a shift toward network-centric and information-dominant air operations. Chengdu J-20. Created as a 5th-generation stealth fighter, this aircraft emphasized low observability, long-range sensors, and first strike capability. It introduced advanced avionics and stealth shaping into frontline service. Its deployment signaled entry into the era of modern stealth air power. Shenyang J-35. Developed as a next-generation stealth design, this aircraft focused on carrier compatibility and reduced radar signature. Intended for future naval and expeditionary roles, it reflects continued investment in 5th-generation technology. Its development highlights ambitions for a fully modern carrier air wing. Up next, bombers and strategic strike aircraft. Xian H-6. Developed as a long-range bomber platform, this aircraft became the backbone of strategic strike capability. Over time, extensive upgrades improved engines, avionics, sensors, and weapons integration. Modern variants expanded its role to include cruise missile launch and maritime strike, extending reach far beyond earlier generations. Xian H-20. Designed as a next-generation strategic bomber, this aircraft is intended to emphasize stealth, long range, and deep strike capability. It represents a shift toward modern, low-observable design and networked warfare. Once operational, it is expected to significantly expand strategic deterrence and global reach. Continuing with transport and special mission aircraft, Y-20, designed as a heavy strategic airlifter, this aircraft focuses on long-range transport of troops, vehicles, and equipment. It supports rapid deployment and humanitarian missions across vast distances. Modern avionics and high payload capacity place it at the core of large-scale air mobility operations. Y-10, developed as an indigenous large jet project, this aircraft represented early ambitions in long-range transport and airliner design. Although it never entered mass production, the program provided valuable experience in large airframe engineering. Its development influenced later transport and aerospace initiatives. KJ-2000, built for airborne early warning and command missions, this platform integrates powerful radar systems for long-range surveillance. It provides real-time situational awareness and battle management capability. Operating as a force multiplier, it significantly enhances coordination of air and naval operations. KJ-500, designed as a more modern and flexible surveillance platform, this aircraft emphasizes improved radar coverage and networked operations. It supports air defense, strike coordination, and maritime monitoring. Its compact design allows broader deployment compared to earlier systems. Then we see trainer and light aircraft, Hongdu JL-8. Designed as a basic jet trainer, this aircraft focused on reliability, ease of handling, and cost-effective pilot training. It prepared new pilots for transition to frontline fighters by introducing jet performance and modern flight characteristics. Widespread use made it a foundational element of pilot development programs. Hongdu JL-10. Developed as an advanced lead-in fighter trainer, this aircraft emphasized high agility, digital avionics, and modern flight control systems. It allowed pilots to train for 4th and 5th generation fighters before operational conversion. Its performance blurred the line between trainer and light combat aircraft. The journey ends with unmanned aerial vehicles, UAVs/drones, Wing Lung. Designed as a medium-altitude long-endurance drone, this platform focused on surveillance and precision strike missions. It combined reconnaissance sensors with guided munitions for battlefield use. Its export success demonstrated growing confidence in indigenous unmanned aviation capability. CH-4. Built for armed reconnaissance, this drone emphasized endurance, payload flexibility, and cost-effective operations. It supported intelligence gathering and precision attacks in contested environments. Its design reflected lessons learned from earlier unmanned systems and real-world operations. CH-5. Developed as a larger and more capable successor, this platform focused on extended range and heavier payloads. Improved sensors and weapons integration allowed more complex mission profiles. It represented a shift toward long-duration strike and surveillance roles. GJ-11. Designed as a stealth unmanned combat aircraft, this platform emphasized low observability and deep strike capability. Its flying wing design supports penetration of heavily defended airspace. Development of this system signals movement toward next-generation autonomous strike concepts.